By the end of this lesson, you should be able to recognize periodic motion in graphs, graph a periodic function based on a description of its motion, and last, determine a periodic function's amplitude, axis of the curve, and period. So those will be 3 new words, as well as what the heck periodic means. So if you haven't watched the video on the Singapore flyer, watch it now. I know it seems silly, but it's kind of a fun way to learn periodic functions. So if you watch it, it's someone that is sitting on top of the Singapore flyer, which used to be the largest Ferris wheel in the world, but is no longer because of the high roller in Las Vegas. So as you're sitting on the Ferris wheel and the person has videotaped it, they've sped it up so that they go in one rotation for 60 seconds. And what we're going to do is we're going to graph what that person's height would look like if we were to graph it on an XY grid. So really quickly, just up in the corner, draw a quick sketch of what you think the person's height is or looks like as time passes on sitting on the Singapore flyer. So try drawing something right here really quickly. So hopefully you've drawn something, because the more that you participate, the easier you're going to understand this lesson. So if this was time and this was height, maybe you drew something like this. Something like that, perhaps. Did you close your circle? Maybe you drew something like this. So we're going to break it down step by step and figure out what the heck a person's height would look like if they were going to go around and around and around this Ferris wheel. So here are the facts you need to know to be able to graph this thing. 1, the highest point of the Singapore flyer reaches a height of 165 meters. So if we were to just sort of put a little indication here that the highest height is 165. So the height of the entire Ferris wheel is 165 meters. And the diameter of the wheel is 150 meters. So we're talking from here to here only is 150 meters. Which means that this little guy down here must be 15 meters in order so that 150 plus 15 will make the full 165. So I find the easiest way to graph these sort of difficult height problems is to first make a table of values. So we know a little bit about the time because in the video the person sped it up so that it was 60 seconds around the entire wheel. So we know in real life it's going to go slowly, slowly, slowly up and around, but let's stick to what the time was in the video. So we know an entire rotation is 60 seconds. So let's start to fill in what we know. So we know at a time of 0, what is the height of the person? Well, we could assume a bunch of things. We could say that time starts here or time starts here. Let's assume together that time starts as soon as you get on the ride, which is here. So what is your height at time 0? It's not 0, it's going to be 15 because you're not on the ground, you're actually above on this sort of stand thing. So our first height's going to be 15. And then let's record a height at every single quarter. So we've recorded a height at 0. We'll do one at the quarter mark, the halfway mark, the 3/4 mark, and let's come back down. So let's skip 1, 2, 3 points. So 1, 2, 3. Let's go back to what happens at 60 seconds. So after 60 seconds, according to the video, we've gone around 1 time. So our height should be back at 15 after 60 seconds. So let's figure out what happened between 0 and 60 seconds. So if we were to do the halfway mark, how long would it take us to get all the way up there? Well, it must be 30 seconds. So 30 seconds, we're going to be at a height of that maximum height, 165 meters. So we've got 165. Let's do the quarter mark. So if it took us 30 seconds to get halfway through, well, it's going to take us 15 seconds to get a quarter up. And the question is, what is our height? Well, the height of the radius of the wheel, so half of the wheel is 75. So at this point, we're not 75 meters above the ground. We're 75 plus 15 meters above the ground. So that's going to be a total of 90. So we're 90 meters above the ground at the quarter mark. One more time. Again, that's the radius of the wheel, so half the diameter, 75, plus the little stand, because we're right up here. So 75 plus 15. So we've got our quarter mark, our halfway mark. Our 3/4 mark is going to happen after another 15 seconds, between 30 and 60. And so 45 seconds. And our height's going to be the exact same as it was over there. So after 45 seconds, it's going to take us, we're going to be at a height at 90 again. So let's take a look at what this graph would look like. So I'm going to do up a quick scale for our time. I'll probably go up by 15s, and heights I'm going to go up by 10s. So now that the scale is done, we can start to graph this guy. So our first point is going to be 0 and 15, so it's going to be about here. Our next point is 15 seconds and 90. So right here. Then we've got 30 seconds and 165, so we're all the way at the top, 165. And then we've got 45 back to 90. 45 back to 90, which is right here. And 60 back to 15. It's going to look like this. So if we were to connect it, these are not going to connect in linear lines, and that's because the height is not changing in a linear fashion. So if we were to go back up to here, taking a look at our Ferris wheel, as we're going up, here our height is slowly increasing, and here it's really quickly increasing. So you can just see the rate of change down here is much less than the rate of change up here. So we're not going up our height is not increasing in a constant matter. Here the height is increasing and slowly increasing here as we can go around. So what that's going to look like is, if we were to draw more points on this, what we would realize is that it would all connect with a curve. So the curve would look something like this. So it comes up and it comes back down. Oops. We're going to try that again. So it's going to come up in a curve and come back down in a curve. Again, not linear lines because the height's not increasing linearly. If we were to add some more points to this, let's say we go around for a second time, what would this look like? Well, we can see that the pattern in our time is that we're hitting a quarter of the Ferris wheel every 15 seconds. So if I add another 15 seconds, I have 75, and then 90, and then 105, and 120. And 120 makes sense because that's 60 times 2, so that's 2 minutes. And our heights are going to repeat as well. So at 75 seconds, so at 60 seconds we're at the bottom. 75 seconds we're at the quarter mark, which means that our height's going to be 90. At 90 seconds we're all the way at the top, so our height's going to be 165. At 105 we're back around to the other quarter, so we're at 90. And at 120 we're back at on the ground, so we're at 15. So if we were to graph that really quickly, a second cycle, at 75 seconds, we're at a height of 90. So we are up here. At 90 seconds, we're at the max height of 165. At 105, we're back to 90. And at 120, we're back home at 15. So if I connect this again, it's going to connect into a nice smooth curve like this. And if we were to go through, now my curve is not lovely, it's not perfect, you can probably make a better one. If we were to do a third cycle around the Ferris wheel, we know there would just be this shape that would repeat again, and a fourth, it would repeat and repeat and repeat. And this is what we call a periodic function, something that repeats over and over and over again. So also, I said function because this is a function. It passes the vertical line test. Whoops. It passes the vertical line test here. So when we originally looked at this problem, if you were someone that drew it anticipating that it was going to make a circle, what you forgot is that time can't loop back in on itself. So time is going to continue as we record, which is why this is a function, because there can only be one height at one time. So now that we have a bit of an introduction of what a periodic function is, remember a periodic function is a function that has a pattern of y values that are repeated over and over and over again as the x values change. So there's only one y value for every single x value, which makes it still a function. So there's three pieces of terminology that are going to come up often when we talk about periodic function. One is called the period. next is the amplitude, and then we have equation of the axis of the curve. So one complete pattern is called a cycle. And I was already using this word when we were talking about going around the Ferris wheel. So it makes sense. One cycle is one trip around the Ferris wheel. A cycle may begin at any point on the graph. So we decided to start at the bottom of the Ferris wheel, but we could have said time started at the quarter mark, and we were marking every time we were to go around an entire circle from the quarter mark. The horizontal length of one cycle is called the period of the function. So that's what that means. One complete pattern is called the cycle, and it's the smallest pattern that repeats over and over again. And the period is the length of that cycle. So taking a look at this guy here, can you see the pattern that repeats over and over again? The smallest pattern possible. So you might say, oh, well, the whole thing repeats. Well, there's a smaller chunk of that we can say repeats over and over and over again. So try to see if you can see it and highlight what you think one pattern that is just repeated over and over and over again is. So what did you come up with? You could have seen a bunch of different options. So one thing that maybe you saw was this. So is that considered to be one cycle? Well, one cycle would mean that if this is the cycle, then it's this little shape that's going to repeat over and over and over again. And doesn't it? If I were to take this V, doesn't it repeat over here? Doesn't it repeat over here, over here? So it's like if I could take this, cut it out, and just paste it, paste it, paste it. Yes, so this is considered to be one cycle. Let's do another one. So maybe you saw this. Oops. Let's try that again. Maybe you saw this. Maybe you saw the hat upside down. So does that shape repeat over and over and over again? So we've got a zigzag, another one, another one. Yes. The answer to that is yes. Maybe you saw something completely different. Maybe you saw this. Because that pattern also repeats over and over again. So here it is once. Here it is again right beside. Here it is a third time. So as long as it starts and ends in the same place, we're good. Just like the blue, starts and ends in the same place, starts and ends in the same place, as long as it's a continuous graph. So we've got a whole bunch of options to choose from. So because I can see the blue one the clearest right now because I've gone over it, it says, for example, the period of the function of the graph below is blah, blah, blah. So we've got to figure out how long this cycle is. So if this is -1 and this is 1, that means our units are 1. It starts at -2 and ends at 2. So the length of the cycle must be 1, 2, 3, 4. So it doesn't matter which one you chose, the length would be 4 units. So if you chose the green one, if you chose the blue one, and you chose the yellow one, no matter what, our period is going to be the same. The last two words that we're going to learn are amplitude and axis of the curve. So amplitude is going to come in handy, especially when we're graphing sinusoidal functions. So we're going to get to graph sine functions and cosine functions next. So it says for any periodic function, so it's a repeating function, the amplitude of the function is defined as half the difference between the max and the minimum of the function. So what that means, if we were to take the max minus the min and cut it in half, it's the length of that little line. So really, it's the length from the middle to the top. So before we really dig into amplitude, I'm going to look at this other word, or this other term. It's called axis of the curve. The axis of the curve is the horizontal line that cuts the periodic curve in half. So it's the middle line. So if we can define the axis of the curve as the middle line, the amplitude is the distance from the top to the middle or the bottom to the middle. But because it's the middle, it doesn't matter because the top to the middle and the bottom to the middle, by definition, has to be the same thing. So first let's find the axis of the curve, and then we're going to use that to find the amplitude, or visually we'll use it. So you can already see that the equations for this, or the shortcuts to find this, are very, very similar. So here's the way I remember it. Axis of the curve, it is the middle. So that's this guy right over here. It's the middle. So to find the middle of anything, think of finding the average. We would add the highest plus the lowest and divide by 2. So that's what this formula is saying. So it's saying to take the maximum value. In this case, the maximum value looks to be about 5. So let's say that the maximum is 5. And then plus the min looks to be -5. And then divide that by 2. this is going to give us 0 over 2. And the axis of the curve is the line y equals 0. So again, it's a line, so we're not just going to put 0, y equals 0. And that looks to be about right. Looks like the middle is right at the x-axis here. So now let's take a look at the amplitude. So if the axis of the curve is the middle, remember the amplitude is the distance from the top to the middle or the bottom to the middle. So it can be found by taking the max minus the min and dividing that by 2, because we're looking for a distance now, not the middle. So the amplitude is going to be the maximum, which we approximated as 5, minus the minimum, which we approximate as -5, divided by 2. And that's going to be 10 over 2, which is 5. So the amplitude is 5, the length from the top to the middle. That makes sense because our middle is 0, our top is 5, and our axis of the curve is y equals 0. So now try out the new words that you've learned, period, amplitude, and equation of the axis of the curve, and apply it to our Singapore flyer example. So go back to our first page, approximate what you think the period is, the amplitude, and the axis of the curve, and then come back and check the video. Okay, so if you're coming back to the video, you've taken a look at what we did on the first page and seen if you could figure out the period, amplitude, and axis of the curve on your own. So the period of one cycle is 60 seconds. That was one trip around the Ferris wheel, lasted 60 seconds. So that one curve repeats over and over and over again. And the length of that little cycle was 60 seconds. So it started at 0, ended at 60. The amplitude was the maximum minus the minimum divided by 2. And the maximum is 165. Subtract the minimum, which is 15, divide that by 2, and you get 75 meters. That also ended up being the radius. So that was the radius of the wheel. Okay, next we have the equation of the axis of the curve. What line cut that curve exactly in half? Well, add the 2 and add the max and the min, divide by 2. So if you were to take 165 plus 15 divided by 2, we get the line y equals 90. Make sure you include that y. So if you were to graph it, that line y equals 90 should cut the graph exactly in half. So let's practice again with this crazy looking graph. The question is this periodic? That just means, is this repeating? Are the y values repeating over and over and over again? Well, yeah, maybe you see that this is the pattern that's repeating and this is the pattern that's repeating. So if I were to just highlight very quickly the pattern that's repeating, is this a suffice answer? Is that little point what is repeating over and over again? No, because if it was, there would be another point right beside, and another point beside that. We have to include this little bit right here. So don't forget to include that. This is the piece that's repeating over and over and over again. So if we were to cut and paste this over and over and over again, that's what would make this pattern. So we can think of one cycle as this little guy right here. So the question says, find the period. So the period would just be the length of that cycle. So the period would be the length from 0 to 2, and so that would be 2. Next it says to find the max and the min. Well, that's very easy. The maximum value that this reaches is 1, and the minimum is 0. And last it asks for the amplitude. What's the distance from the middle of the graph to the top? Well, maybe mental math, you can just figure out the middle's got to be 0.5. And so the distance from 1 to 0.5 is going to be 0.5. So if you're not following, let's just triple check. Our amplitude is going to be found by taking the maximum, subtracting the minimum, and dividing by 2 because we're finding a distance. So we're going to have 1 over 2, which is 0.5. So our amplitude is 0.5 units. So now try this next example on your own. It says to sketch a graph of a periodic function. That means a repeating function given the period and the amplitude. So I want you to draw at least 2 cycles. So at least 2 cycles. And the period of it has to be 6 and the amplitude has to be 4. So it's way easier if you watch me do it, but that doesn't mean you're going to learn it yourself. So try something on your own and in class show it to me and ask if you're on the right track. So you should only be playing the video at this point if you have a graph drawn in here, because we're going to do a quick checklist to see if you have a graph that has a period of 6, amplitude of 4, and is periodic. So I'll just work out my own solution for you, just so you can see how I would think about this. So if the period is 6, I know one way to do it is map it out, knowing that it has to have a length of 6. Therefore, why don't I start it at 0 and end it at 6? And that's going to for sure ensure that my length is 6. Or you can go -3 to 3 or -2 to 4, as long as that length is 6. Just my head, I think it's easiest to go from 0 to 6. The amplitude has to be 4, which means the middle of the graph to the top has to be 4, and the middle of the graph to the bottom has to be 4. So it all depends on where you put your middle. So if you put your middle at 0, that's going to be easy. Well, I'm going to make it slightly harder. I'm going to put my middle at 2. So maybe I'm just going to do a dotted line across to represent the axis of the curve. So that's the middle of the graph. If the amplitude is 4, that means the highest point of the graph has to be 6, because the distance from the middle to the top has to be 4, and the lowest graph has to be the lowest point has to be -2. So just triple checking before I connect all of these. The amplitude from the middle to the top has to be 4, it is, and from the middle to the bottom has to be 4, and now all I have to do is connect these. So if I decide to make these points here, here is my shape that I'm going to repeat over and over and over again. So if I'm going to repeat it one more time, I know maybe if I'm going to repeat it on this side now, then I know that I have to start it at -6 and end it at 6. I decided to make my point 2 spots over. So 2 spots over is going to be my highest point, which is going to be right here. So at -4. So I'm going to put a big dot at -4. I decided to make my lowest point 2 spots over from the end. So I'm going to start it at this, or I'm going to end it at this guy right here. And so if I connect it now, it should make the second, oh, there we go, second cycle of my pattern. It's not perfect. You probably have a ruler. I do not. And so I've created a graph that has a period of 6 and amplitude of 4. So do a quick checklist for yourself. So first, did you graph 2 cycles? Check or check. If not, graph a second cycle. Second, for one of your cycles, is it 6 units long? So actually count it from beginning to end. Is it only 6 units? Check that. And then lastly, amplitude. Figure where the middle of your graph is, and then calculate what's the distance from the middle to the top and the middle to the bottom, and both have to be 4. All right, let's try this last question. So it says a periodic function. First of all, we know what that means. It means it's going to repeat, the y values are going to repeat over and over again. It has a period of 12, which means those y values are going to repeat every 12 units. Then it says if f at 7 is -2 and f at 11 is 9, determine the value of f at 43. So how the heck are we going to find that when we're only given this information? We're given tiny little clues to find this guy all the way over here. So let's try to take those clues and maybe put them into a table of values. Maybe that will help us. So I'm going to make a quick t-table. And let's fill in the information that we know. So we don't know what we're measuring, so we'll just use x and y. We're given a clue. We're given the fact that f at 7 is -2. So that means when x is 7, y is -2. So we're given 1 point. And we're given f at 11 is equal to 9. So when x is 11, y must be 9. The other clue that we're given is that it has a period of 12. That means that every 12 units, the y values are going to repeat. So to understand what this is going to look like, let's go back to our Ferris wheel. We know that the period of this Ferris wheel is 60. So one cycle is a length of 60. That means that every 60 units, the y values are going to repeat. So here it is once, here it is twice. But we've been looking at it from the start. How about like right smack in the middle? So at 15 seconds, our height is 90. What's going to happen in another 60 seconds? So what's 15 plus 60? It's 75. Look at our y value. It's repeated. Let's try the top. So at 30 seconds, our height is 165. Let's add 60 to it. Well, 30 plus 60 is 90. Let's go to 90. The y value is repeated. So we don't have to just add the period to the start. We can add the period to any point we were given, and we're going to get that same y value again. So now let's come back to our problem. We're given the period is 12, and we're given these 2 points. So if we keep adding 12 to 7 and keep adding 12 to 11, we're going to know what the points are because the y values are going to repeat. So if we keep adding 12 to both these numbers, hopefully we come to 43. If not, we're really screwed. So I'm just going to extend my t-table here. And let's start with 7. Let's add 12 units to 7. Oh gosh, having some issues. Plus 12. There we go. Okay, so if I add 12 to 7, I'm going to get 19. So I know at 19, my y value is going to be -2 again. Let's add another 12 to 19. So add another 12 to 19. We get 31. And again, my y value is -2. So let's add 12 to 11 now. If I also add 12 to 11, again, I'm having issues. Okay, if I add 12 to 11, we get 23. And that y value should be 9 because that came from the 11. We add 12, 23. If we add another 12 to 23 plus 12, we're going to get 35. And then that value is going to be 9. And let's keep on going. So let's add another 12 to 35 since we're here. We're going to get 47. And that value is going to be 9. So again, we're looking for 43. So this adding 12 to 11 didn't help us out. It didn't give us 43. So hopefully if we add 12 to 31, we're going to get 43. So if we add 12 to 31, we are going to get 43. And we know that y value's got to be -2. So we found our answer. Ta-da! F at 43 is equal to -2.